Welcome to Probability and Statistics. In this lecture video, we're going to learn how to find the values of a normal distribution random variable. So what we're going to do here is a little bit opposite compared to what we did on the last lecture video. So the last lecture video, the problem gave us a random variable x, the mean, standard deviation, and then we find the z-score, so we can actually do the normal CDF to find the area under the curve. Now what we're gonna do is opposite. Okay, now the problem will give me the area under the curve. Then I can find the z-score first, or I can find the z-score then find other things, okay, that was in the formula. Okay, so once I got my z-score, okay, I can actually go a step further and finding my random variable x, my mean, or the standard deviation, depends on what the problem says. Alright, so just to find the z-score, okay, we can either look up the closest probability in the table or use our graphing calculator to do it. So if we're going to do this by the graphing calculator, we're going to go back to second vars, go back to distribution again. This time we will look for something called inverse norm. Okay, inverse norm number 3. And what we're going to enter inside the parenthesis is the area to the left, comma 0, comma 1. Mean is at 0, area is, the mean is 0, the standard deviation is 1 at a time. Alright, so let me kind of write this out real quick. Let me see if I can type it. So when we use the normal CDF, okay, we use normal CDF because that will lead to finding the area under the curve. Let me just say area. Alright. I'm going to say by given okay, excuse me, I'm going to say it this way, okay, normal CDF will actually tell us to find the z-score so we can find the area on the curve. Alright, then area. Now the inverse norm, that means we will actually learn, I didn't say it right. Normal CDF is finding the area. Okay. Inverse norm is actually finding z-score. There you go. Okay. It's kind of weird if we can't keep this if we can't get this thing straight, we're gonna end up using the wrong thing. So this part, for example, this problem says find the value of z. So that means I got to find z-score such that the 0.13 of the area lies to the left of the z. So the problem give me the area to the left. Which is 0.13. Okay. So if I want to find the z-score and then give me the area to the left, then we will use the inverse norm. And inside the parenthesis, we will type in the area to the left, comma 0, comma 1. Alright, that will give me the z-score. Round to 2 decimal places. So number 3, inverse norm, 0.13, comma 0, comma 1. If I round to 2 decimal places, that's negative 1.13. And that's it. Alright, for right now. Other example will take a step further. So this answer is actually my z-score. Okay. Alright, let's check it out. This one. Find the value of z such that 0.9722 of the area lies in between two z-scores. Okay, so let's think about this. I'm going to go take this picture real quick. So right now, what the problem is saying in terms of a picture is I have two z-scores. One of them is negative z. The other one is positive z. And the area in between them, the area in between them is 0.9722. So all this area in between the two z-score is 0.9722. So remember now, when I put it in the inverse norm, I got to type in area to the left. So area to the left. So if they give me an area in the middle, how do I find the area to the left of one z-score, of one of the two z-score? So I'm gonna look at this negative z-score to the left. What is this area to the left of my negative z-score right here? Okay. So the area to the left of my negative z-score, how do I find that? Well, if I know the area in the middle, and if I take 1 minus the area in the middle, that will give me my two tails, right? If I take 1 minus what's the area in the middle, that will give me the area of the two tails. And I just need one of the two tails. So we will take 1 minus, I'm going to draw it up. I'm going to just write it out. We will take 1 minus the area that's in the middle. And once I subtract it, it will give me the area of the two tails. And I just need one tail. So I've got to divide it by 2. Why? Because it's symmetric. Okay, bell curve shape is symmetric. And they are trying to tell me that these two z-score will just have an opposite sign. So 1 minus 0.9722. The area of the two tail together is 0.0287. 0.0278, excuse me. And divide that by 2. That'll be 0.0139. Alright, so the area to the left of my negative z-score is 0.0139. As a matter of fact, the area to the right of my positive z-score will also be the same thing. So if I do the inverse norm and type in the area to the left of this, of my 0.139, what it's going to give me is this negative z-score. It got to be, because this is the one I'm thinking about right now. This gets a little bit confusing after a while. So if I type in 0.0139, comma 0, comma 1, inverse norm, alright, that gave me negative 2.20. We know it's negative because this is the area I'm looking at. Alright, now if this one is going to be the negative 2.20, and you know the area to the right of my positive z is the same area, okay, by being symmetric, that z-score got to be the positive 2.20, okay, because if you think about it for a minute, how much area is to the left of this positive 2.20? Well, the 0.9772 plus the 0.0139 together, this whole entire area to the left of my positive 2.20 here is 0.9911. So if I do an inverse norm, typing area to the left, comma 0, comma 1, that will give me my positive 2. A little bit off, 0.9911. Yeah, I'm a little bit off, and I knew it too. 0.9722, 0.0139. Let me make sure I did this right. 1 minus 0.0139. I don't know why it's off so much. Excuse me. Yeah, I knew I was off by something. I'm typing something wrong here. .9722 plus the 0.0139. This is only 0.9861. All right. And the reason why I know the reason why I'm off, because this decimal, this 0.97722 is probably already rounded. Now when I do the inverse norm, area to the left, 0.9861, comma 0, comma 1. There you go, 2.20. So I probably added up wrong when I did it. All right. So what is my z-score? My actual answer, I will actually type in a positive one. I don't know why the homework does that. They want you to type in 2.20 instead of negative here. All right. Even though we know it's just saying that the 2z score is the same number, 2.20. It's just the one is negative. Okay, the one on the left side is negative. The one on the right is positive. They just want me to type in the positive one. Alright, so to find the area to the left, you got to pick one of the two z-scores. Okay, so I took 1 minus the area in the middle, that give me 2 tails, divided by 2, that give me the area of each tail. So if I got 1 tail, alright, if I got 1 tail, then if I only got 1 tail here, and the tail I'm looking at is the one on the left side, then that will give me a negative z-score. Alright. So, let's take a look, okay? Once I can find the z-score, now we can actually find other things in the formula. I'm going to put up this formula right here so we can look at this. Score on the test has a mean of 71.6. So I got my mean. 6% of the score are above 87. The score have a distribution that is approximately normal. Find the standard deviation. So this problem actually want me to find the standard deviation sigma. Alright, mean is 71.6. 6% of score are above 87, so this 87 got to be my random variable x. Alright, so the problem gave me the mean. Alright, my random variable x, 87. Alright, what does a 6% mean? 6% of score are above 87. So that means the area to the right of 87 is actually 6%, 0.06. Okay, that's what it's trying to say. Okay, because finding the area on the curve is the same thing as a probability. Alright, so the area to the right is of 87 is 0.06. So let me bring this picture in again so I can draw for you. Alright, so right now what I got is mean 71.6. 87 is to the right of it. And the area to the right of 87 this little bit of area right here is 6%. Alright, so I got my random variable x. I got my mean. I'm missing the z-score and the standard deviation. So I got to find the z-score first before I can find the standard deviation. Alright, so that's why we got to do the inverse norm to find the z-score first. Then we can substitute back into this formula. Alright, then we can find our standard deviation. So my inverse norm, area to the left, to the right is 0.06, to the left, type it out so we can all see this. If I got to typing area to the left of 87, I gotta be 0.94. Okay, 1 minus the area to the right, comma 0, comma 1. Second distribute, number 3, 0.94, comma 0, comma 1. 1.55. Alright, so my z-score for the 87 is 1.55. Alright. So once I got my z-score, my x, my mean, now I can find my standard deviation. So that will be 1.55. Set it equal to x, random variable x is 87 minus the mean divided by standard deviation sigma. Alright, so solve for sigma. Let's use the old trick, cross product. We're gonna view 1.55 as 1.55 over 1. So if I use a cross product, 1.55 times sigma, 1.55 sigma. Set it equal to 1 times 87 minus 71.6. 87 minus 71.6. So this is 15.4 up here. 1 times 15.4 is 15.4. Alright, to get sigma by itself, divide both sides by 1.55. Round to the nearest 10th. So 15.4 divided by 1.55. Round to the nearest 10th. Sigma is about 9.9. Alright. So this problem, we got to figure out that the 6% is the area to the right of 87. So we gotta find the area to the left, put it into the inverse norm so I can get a z-score for the 87. Then I can substitute back into the formula to find my sigma. Alright. Let's do another one, okay? Alright, ACT mathematics score normally distributed. The mean is 21.3 and the standard deviation is 5.3. So I got mean and standard deviation A university plans to send letters of recognition to students whose score are in the top 100%. Top 11%. What is the minimum score required for the recognition? So basically what it's saying is I got a mean located at 21.3. I know my standard deviation is 5.3. They will only send the letters of recognition for students who are top 11%. So let's say right here to top means to the right. So let's say from here to the right, let's say this area is the top 11%, 0.11. Okay. So the problem never tell me what score that is, and that is actually what we need to find. Okay. Which is different from this problem. This problem give me the random variable x. This problem don't. So that means what we are trying to do for this problem, if you look at the formula here, is I got mean, I got sigma. I need to find the random variable x, which is what score will give me the top 11%. So to find this random variable x, I got to find the z-score first. Alright. So let's see. If I want to do the inverse norm, what would be the area to the left? I know the area to the right of this score is 0.11. So what's the area to the left? That got to be 1 minus 0.11, which will give me 0.89. So all this area to the left of that score that I'm looking for is 0.89. Alright, so inverse norm. .89, comma 0, comma 1. .23. So this z-score for this unknown score is 1.23. Alright, so now I got my z-score 1.23, set it equal to my random variable x, which I don't know, minus my mean 21.3. Let me use a calculator x, because they all use calculator x, divided by my standard deviation, which is 5.3. Okay, so we'll set it up like this as for proportion. Alright, again, cross product, so that's over 1. So 1 times x minus 21.3 is still going to be x minus 21.3. Set it equal to 1.23 times 5.3. $6.519. Alright, to get x by itself, I got to move my negative 21.3 over, so that become positive. So my x got to equal to 6.519 plus 21.3. Alright, round to the nearest tenth, so that'll be 27.8. So that means this actual score, okay, above this 27.8 is the top 11%. Okay. Then so that means if you score higher than 27.8, which puts you in the top 11%, they will actually send you the letter of recommendation. All right. So both scenario give me the area to the right, so I need to first figure out the area to the left before I can put it into the inverse norm to find the z-score. All right. Let's take a look at this one. The diameter of bolts produced in the machine shop are normally distributed with a mean of 5.66 millimeters, with a standard deviation of 0.03 millimeters. Find the two diameters that separate the top 9% and the bottom 9%. Oh, here we go. Find the actual diameter that will separate the top 9% and the bottom. Alright, so that means here I should have this random variable x. You know what? Let me just call it. I'd rather use a question mark. So there should be a one diameter. I call it x1. There's another diameter called x2. All right. Find the two diameter that separate the top 9% and the bottom 9%. So what it's trying to give me is the area to the right and to the left of these two diameters. Area to the right and left, top and bottom 9%. So that means this area here is 0.09. Okay. So I need to find a z-score for both of these. Okay, first, before I can find the diameter. Alright. So if I do an inverse norm, area to the left, if I do area to the left of my x1, which is using the 0.09, my z-score got to be negative, like I showed y'all earlier. Second distribute 0.09, comma 0, comma 1, negative 1.34. 4 decimal place. Now, so that means the z-score here is negative 1.34. Since the area to the right and to the left are exactly the same, that means this z-score got to be the positive 1.34. Okay, it's symmetric. The area is the same, therefore the two z-scores are the same. It just one is positive, one is negative. To the right of the mean, to the left of the mean. All right. So if I set this up, because the problem gave me the mean and the standard deviation, our job is to find the two random variable x. So let's do the one on the left. Okay. So if I follow my formula again, okay, make sure you can find that formula on the formula sheet. Alright, let's do the one on the left with a negative 1.34. Set it equal to the random variable x1 minus the mean 5.66 divided by the standard deviation 0.03. Okay, so the setup on the right got to be the same thing, except it's a positive 1.34 I'm using. Alright, cross product again. X1 minus 5.66 So the equal to negative 1.34 times 0.03, negative 0.0402. So here on the right, that 0.0402, 402, sorry about that, there's a 0 right there. Okay, that 0.0402 got to be positive. Alright, that's the difference. So the one on the left, negative 0.0402, move the negative 5.6 is over, become positive. So plus 5.66, wrong to nearest 100, so that will be 5.62 millimeters. Alright, the other one, the 0.0402 is positive, move my 5.6 is over, become positive 5.66, so that will be 5.70. Okay, so these are the two diameters. Okay, these are the two diameters that will give me the top 9% and the bottom 9%. Okay, these are the two diameters that separate the top and the bottom 9%. Alright, got a real neat problem here. This is real cool. Let's say an English professor assigns letter grade on a test according to the following scheme. A will be the top 7% of scores, B is below the top 7, above bottom, 59%. Okay, C is this scenario, D is this scheme, F is bottom 8% of scores. So it only assigns letter grade based on, based on certain percentage, where student falls. Kind of weird, because for our class to get an A is for right now is what, we're on the 7-point scale, so that is actually top. A is actually top 93, so our A is the top 7%. Okay, just like the same one right here. But B does not. B is below the top 7, but above the bottom 59. So I will show you how this picture represents. Now the key thing is reading here, reading the actual question. The score on our test are normally distributed with a mean of 75.7. So the mean is 75.7 and a standard deviation of 8.8. Find the numerical limit for C grade. So this problem is about finding the grade C, which is right here. How do I get a C? Okay, what test grade I need to make on the test to get a C to fall into this scheme? Alright, so let me bring this picture again. So the grading scheme for a C, that's what this problem want you to find. It says top 41%. So let's say mean is right here. Okay, pretend the top 41%. So let's say this point to the right is the 41%. All right. And above the bottom 18%. What does that mean? Above the bottom 18%. Excuse me. above the bottom 18%. Bottom is from the left. So anything from the very left, okay, all the way up to your score is the what is above the bottom 18%. That's what it says. I know the wording is kind of weird because you can't really say below the bottom 18%. You know what I'm saying? You can't really say below the bottom because below the bottom is, you know, there's no negative scores. So above the bottom 18% is referring to this end. Below the top 41%. Okay. Below the top 81%. Because in a minute you'll understand why they use the word below the top or above the bottom. Alright, so this is where 18% is. So remember now, the question asking what score, these two score, one here, will give me a C. Okay. So the problem gave me the area to the left of one score. The problem gave me the area to the right of the higher score. Alright. So I got two different areas. So I got to find two different z-scores. Okay. And I'm gonna set it up finding the random variable x. Alright, so let's do some inverse norm real quick. Let's focus on the one on the left. Alright, the one on the left. Area to the left is 0.18, comma 0, comma 1. So the z-score is negative 0.92. Alright. So this z-score is negative 0.92. So let's follow the formula. The z-score, negative 0.92. Set it equal to my random variable x minus the mean, 75.7. Divided by standard deviation 8.8. I'll use a little cross product. 1 times the random variable x minus that is still the same thing. So they equal to negative 0.92 times 8.8. Negative 8.096. Alright, to get my random variable x by itself, move this term over, become positive. So that will be plus 75.7. So round to near 10. So that, excuse me, round to nearest whole number. So that's about 68. Alright, so this score is 68. So if you can be above the bottom 8%, above the bottom 18%. So this 68 is actually above the bottom 18%. Alright, so let's see what this score is. So inverse norm again. This time I got to do area to the left. So if the area to the right is 0.41, what's the area to the left? 1 minus 0.41, which is 0.59. So area to the left, 0.59, comma 0, comma 1. So second distribute, number 3. Alright, so that'll be 0.23. So the z-score here is 0.23. Alright, so let's set it up. 0.23. So they equal to the other score minus the mean divided by the standard deviation. So, alright, so if I use a cross product again, just like I did on the left side here, 0.23 times 8.8, 2.024. Move this one over. Move the negative 75.7 over. The other score. Plus 75.7. Round to nearest whole number. That's about 78. Alright, so the other score is 78. So a C, which is above the bottom 18%, below the top 41%, is the score 68 to 78. That's a C for this scenario. Okay. All right. Real interesting problem. Real interesting. All right. One last thing I want to talk about before we. I think this is a good place to show you this. Something called Z sub alpha. Z sub alpha. Alright, Z sub alpha is referring to the Z-score, okay, such that the area under the standard normal curve is to the right, which is alpha. Alright, so when we say Z, for example, if I would say Z sub 0.1, that means that 0.1 is the area to the right. Okay, that's the area to the right. It's called Z sub alpha. So what you're trying to do here for Z sub 0.1 is learning how to find the Z score. Okay, this is actually telling you the area to the right is this. Tell me what is that Z score right there. So if the area to the right is 0.1, that means the area to the left is 0.9, comma 0, comma 1. So the Z score is 1.28. Okay, so this answer representing a Z score under the normal curve. Okay, keep this in mind. We actually need it beginning with chapter 7 and rest of the semester. We'll once in a while you will hear me talking about Z sub something. Okay, so for right now, just remember Z sub alpha is referring to finding the Z score by giving you the area to the right. Alright, that will conclude this lecture video. Thank you for